we're going to take a look at a few other concepts for Java Server Faces, which will include looking at the various scopes that are available to our components, attributes that we can put on scopes, templates for getting a consistent look and feel about our websites, and finally, the magic is demystified, JSF validators. So you're going to need all of this from previous learning blocks. The managed beans and lifecycle, of course, because that is prevalent right the way throughout JSF applications. Also from last learning block, MVC. And hopefully by the time you've finished those tutorial worksheets from learning block 3, you should have a much clearer idea of MVC. So let's start off with something about scopes. A scope defines a visibility or accessibility of components. And if we add something to a scope, then it is available only within that scope. And there are various scopes that are available for managed beans in JSF, which are listed here: request, session, application, also conversation and dependent. I'm going to give you a quick overview of these, and then we'll take a look at how they could be used. So a request scope has a short duration, by which we mean it will begin when the request arrives from the client. As part of setting up the request within the JSF container, there will be an object called request that is set up as well. Now, when we're using servlets, we actually see that request as a parameter on method calls. Now, in Java Server Faces, we don't tend to see that object, but it is still accessible to us. That object will stay in existence for the duration of that request. So as soon as the final view for that request has been rendered and the JSF control servlet has determined that this is the end of the request, then that request object is deleted. So very short-lived, just a few milliseconds probably. It is accessible by any JSF component that is processing that request. So it might be that the request is sent to a Java Server Faces bean, a managed bean, and then from a bean off to something else. Well, whatever components are processing that request object have access to it. And they can get access to it in this way, which is shown here at the bottom of the screen, by calling from Faces context class the getCurrentInstance method, from that get external context, and from that get request. That will return as a reference of type object. So we must typecast it so that it is of the correct type, which is HTTP servlet request. And then we can access the methods that are within that object. A longer existence of scope is session. This tends to be quite long. It could be many minutes or even hours. A session begins when the first request from a client arrives. And you're probably used to this concept. For example, logging in at the beginning of some interaction with your bank. And then you don't have to sign in on the next request or the next request or the next request. As long as you keep using that website, your session stays active. And then when you log out, the session expires. There is another way of expiry, and that is to time out. So if a request comes in, and then it's a very long time before another request, at some point, and this is a value that's set in the server, maybe 30 minutes or 40 minutes or 5 minutes, it depends. If there are no requests within that timeout period, the session will expire. We can access the session scope from any of the components that are processing any requests that are within that same session. So the session scope is actually quite useful. Let's say, for example, you want to store the Oracle database username and password. You could ask for that on the first request, and then on the third request you might need it again. Well, if you've stored those credentials in the session scope, then you can retrieve them from the session scope on that third request and then use them without having to ask the user to supply them again. Access to that session object is very similar to the request, except that we call get session instead of get request. The application scope exists for the longest time. That could be many weeks or months even. And will begin when the application is deployed to the web server and will terminate when the application is removed from the web server. There is only one such object for the entire application. So any attributes or any values that are stored in the application scope will be accessible to every single component on every single request from every single client. So we need to make sure that the values we store here are genuinely supposed to be accessible to every single user of the application. Now, the great thing about these scopes is that they have very well-defined boundaries. For example, if you are operating within a request and you store some value in that request scope, then it is only accessible to other components accessing that one request object. If you've got two requests taking place at the same time, so you've got two clients and they simultaneously send in a request, they will each get their own request scope and they cannot see each other's requests. So there's complete isolation between the request objects. Also, between requests from the same client. Now, these will not be concurrent but sequential, and because the first request will have terminated before the second request is processed, the first request object and scope will disappear before the second request begins. Likewise with sessions. Sessions belong to a particular client. So if you've got on your computer a web browser and you send a request in, your web browser is the client. If you were to close that web browser and open a new web browser, that is essentially another client, a different client. Anything that is within that session can access that. So requests from the same client within the same session will have access to this scope. But if you've got multiple clients operating in parallel, then they will not be able to access each other's scope. As I mentioned earlier, the application scope exists for all clients and all sessions and all requests. So be very careful what information you put in there. If it's truly common, maybe the day's exchange rates for a currency application. That might be information that is suitable for putting in the application scope because everybody wants to make use of the same data. And because there's only one instance of it, then everybody can use it. Whereas if you were to put that information into every session, then if you've got 1,000 users, there are going to be 1,000 copies of it. It's important to think about number of copies. Do you want one per request, one per client, one per application? And then make use of the scopes accordingly. So here's an illustration of scope duration. Time passes from left to right. The web server has had the application deployed to it, so the application scope exists. Client number 1 sends in a request. So that will create a request scope for that one request, and also a session scope for that client. A little bit later, client 2 sends in a request. So that sets up another request scope, and you can see that even though they exist at the same time, there is isolation between them. And there's also a session created for this second client, also isolated from the session for the first client. A little bit of time passes. Client number 1 and client number 3 send a request simultaneously. This will, for client number 1, not only create a new request scope, but it will also extend the existence of the first client's session. Every time a request arrives, the countdown timer for that session will be reset, and then it will start counting down back towards 0. If ever it hits 0, as it has done in fact for client number 2, then that session will time out and go out of scope. A bit more time passes. Client 3 sends in a second request. Its session scope extends. This time, client 1 has timed out with its session. So we've only got the one scope now in existence for sessions. The application scope is still there. The application hasn't died, so the scope remains. Client 3 has sent in a third request. Maybe it's a logout request. So now we want the session to terminate. We don't want to leave lying around for the next however long, 30, 40 minutes, any data that should have gone when logout was requested. We can programmatically delete a session and terminate it. Well, we can see also that client 1 has sent in a third request, but this was after the session timeout. So the request scope is created for this client, but it is essentially part of a new session. Therefore, a fourth session has been created in our application. So over time, that's how things progress. And we can see by the length of these various bars, the relative duration of each of those scopes. We can allocate managed beans to these scopes through the use of annotations. If we want to place the managed bean into the request scope, then we would simply put the @request_scoped annotation in front of the class declaration. And similarly for session and application scopes. The effect of this is that the control servlet will create a request scoped instance every time a new request comes in, and will delete that request scope managed bean at the end of processing that request. So if you've got a managed bean that is request scoped and you send in 2 requests from the same client for the same bean accessing the same properties, then you will find that the values from the first request will not have been preserved in the bean instance for the second request. Because being request scoped, that managed bean goes out of existence or out of scope at the end of processing that first request. To all intents and purposes, when the second request comes in, you've got a new instance of the managed bean. With a session scoped managed bean, the bean instance will be created when the first request from that client is received and will stay in existence for as long as the session is in existence. And that means that when a second request comes in and makes use of that managed bean, then the values that were put into that bean on the first request will still be there. They are preserved between requests, so long as the session has not timed out. A couple of other scopes that we won't use much of, if any, but I mention them so that you are aware of them. Conversation scope means that there is exactly one associated conversation with every request. As we can see, there are 2 states with that, transient and long running. If it is transient, then it will live and die with the request, and therefore is essentially the same as a request scoped bean. On the other hand, if it's long running, then it will exist between calls to begin and end methods, and it will live beyond the request until the end method is called. It's not quite the same as session scoped, because as you can see on this last point here, it is associated with any request originating from the same JSF view. So when that view sends in its first request, the conversation scope comes into existence. If it is marked as long running, then it will stay in existence. And if the same view is being used to send another request, then it will be available there. So in my mind, it's a bit like using some kind of Ajax thing where you've got the view and it's sending multiple requests without actually refreshing the view. This is a conversation that's taking place between the view and the web server application. The other scope is dependent. It's not really a true scope, it's a pseudo scope. And basically what it means is it is used once and only once and thrown away very quickly, even quicker than a request scope. The last couple of points perhaps make this most obvious, that when we have got an expression language expression inside some view, so for example you might say, I'm binding this UI component in my facelet with a property and a bean. If that bean is marked as dependent, then the bean will come into existence for the evaluation of that expression and will then go out of existence as soon as that evaluation has been completed. So if you've got 2 UI components in the facelet making use of a managed bean that has been set as dependent and is binding to 2 properties, it will actually use 2 different instances of that managed bean, one for each expression. Now we can put attributes into these scopes. The managed beans are automatically put into those scopes by the control servlet. But if we want to store information in there for any purpose, we can access them in the way that was shown on previous slides. We can get a reference to those objects, and we can store objects in those scopes. Basically, we can just add into their collection of attributes our own objects. So we might, for example, say, I want to store some kind of string. Well, string's an object, I can store that. Maybe I want to store an int value. Well, I better make it an integer object first, and then I can store it in the scope. Or I might want to store an array list. That's an object of objects. So that's just one attribute, the array list, containing references to the other objects. And we can put that into the scope as well. And we would do that where perhaps we have some data that needs to be passed from one component to another, but they don't have a reference to each other. We're just saying, okay, there is a component here, typically a model component, might set up some data, and put that data into the scope, and then another component a bit later. It might be another model on a subsequent request, or it might be a view component possibly for the same request or a later request, and say, right, I need to access that attribute that was put into the scope, so pull it down from the scope. So attributes are associated with one scope or another, and the attribute operations that we have are set, get, and remove. So they're the same operation for all of those attributes. The only thing really that differs is the way in which we reference the scope. So where I've got scope in italics here, you substitute in place of the word scope the code that was shown on those previous slides where we were showing how to access those scopes. Why are we wanting to remove attributes from a scope when the scope is going to go out of existence anyway? Well, for something as short-lived as a request scope, we probably would never want to call the remove attribute method because it's going to go out of scope. The only time perhaps that we would want to do that for the request scope is when one component is using it, another component has now used it, and it should be removed so that any subsequent components for that request cannot access it. We would want to use this quite often with session scopes because it might well be that we've got to put it on a session scope for one or two requests later, and then for whatever reason, subsequent requests should not be able to access it, and then we would remove. So you've got to keep in mind not just how long the scope exists for, but these attributes, how long do they need to be available to any other component that is accessing that scope. When you're setting an attribute, you're passing this reference to the object that you want to store in the scope, and you allocate it some name. Put that in as a string. The important thing is, though, that any subsequent access to that via get attribute has got to use exactly the same name with exactly the same mix of uppercase and lowercase letters. Likewise for removing the attribute. If you try to get an attribute using a name that does not exist, either because you've spelt it wrong or because it was never put in there in the first place, then get attribute will return a null pointer. Let's move on now to this idea of a common look and feel for our applications. It's always very helpful to the user to have a consistent layout on your web pages. That consistency can be achieved very easily by using templates. And there are two parts to the template. There is the template itself, which gives you the basic structure. And then there is the content that you want to drop into various parts of the template. The reason we would want to make use of a template instead of hard coding this common look and feel is because of ease of use. If you don't use a template, then you've got to ensure that you type all that structural stuff, all the paragraphs and all the divisions and all the headers and all the rest of it. You've got to type all of that exactly the same in every single facelet. And that's not only tedious to do in the first place, but let's say, oh, I don't want to have that name here, or I've misspelled that name 30 times. You've now got to go and make that correction in 30 places. That's not a good way of developing. You wouldn't do that with ordinary code in a Java file. You'd immediately pull that out and put it into a method, so you've only got the code in one place. Well, that's what a template does for us. It puts into one place the structural code, and then if we want to change that at all, we've only got one place to look. Now, the elements that we're going to use here are in the facelets library. Typically, the label that we associate with that library is UI. So in the template file itself, we'll use the UI insert element. So we'll probably have some standard HTML and facelets code, so bodies and paragraphs and headers and all the rest of it. But there will come a point when you want to say, here is a placeholder for some content. And what you'll do is use the insert element, associating with it, by use of this attribute, a name. This element now becomes a placeholder for something whose name is content. That's my name. Content is my name. You put anything you want there, as long as it's meaningful, really. And you can have as many of these insert elements as you need in that template. just give them a different name so that you can identify them later when you're inserting values. So let's say we have a very simple template just here, a body and a placeholder. If I want to drop something into that placeholder, in my facelet file, so this is a separate file, I'll do something like this. I'll use the UI composition element, and the template attribute identifies the file that I'm using as my template for this content. So there's the first link. From this content, I'm linking back to that template file. So that template file will now be used to render the structural part of the view. And then within that composition, UI define. So there's the third element to say, I am now defining some code to put into that placeholder in the template. If we go back a screen a minute, the placeholder has a name content. So now I am defining some code for that name content. So whatever sits between the define and end define elements, that will be put into the template file where we were saying I'm going to insert this content. Now in the template file, if you have got multiple insert elements, then in the facelet here, you can have multiple define elements. You will use the appropriate name for the appropriate placeholder. And that way, you can very easily have the common look and feel and drop for each facelet the variant code into the invariant template. Now it's time for the magic. For the last 3 learning blocks, I've been talking about this magic, how in some way valid values end up in the managed beans. Now we've pieced together some of the magic because we know that the control servlet, when it is analyzing the input view, will build a component tree and take the values from the form data and put them into that component tree. Part of the magic is getting values of the correct type and valid into the managed bean. What we're going to look at is one part of that magic, which is the validation. Let's say a user's age must be between a certain range of values. Just inputting an integer isn't enough to say that it's valid. Evidently, the string will have to convert to an integer. That's important. But then once it's converted to an integer value, we've then got to think about, is it in the right range? And that's the validation. Now, there are various ways in which we could do the validation. There's one way, which might be the way you immediately think of, which is, well, when the set method gets called for a property to put it into the managed bean, let's do the validation then. But potentially that could be too late. Remember that in the managed bean, we're assuming that all the values are valid. And if we've got, let's say, 4 properties in the managed bean to populate, and the first 3 are validated fine, but then the last one doesn't validate correctly, then we need to be able to send messages back and abort the life cycle and the rest. It could be done, but it's messy to do it from the managed bean. Much better is to perform the validation before we get to that bean. And in the JSF lifecycle, there is a validation stage, which is this one. So here's the lifecycle as we've been looking at it up until now, with the insertion of these 2 things that have been circled. When the component tree is populated, those values are then converted and validated. And only if all of those values are valid, only then will they be copied across into the managed bean. If any one of those validations fail, then the life cycle is aborted. The original view is redisplayed along with some error messages. And that's why we can assume that by the time the values get put into the managed bean, they are not only of the correct type, but they are valid values. So the question remains, how do we define the validation that we want performed on our application? Well, one way is to use some of the attributes that are available in these UI components in the facelet. For example, if something must be there, in other words, the user is required to type a value, then we can use the required attribute for that UI component. For example, this input text, required equals true, so the user has to type it. And if there is no value there, if we use the required message attribute, we can define our own user-friendly message instead of the, shall we say, the user-unfriendly message that would come out of the standard system. There's another bit of validation here as well. There's a max length attribute. saying you cannot exceed 25 characters. If you do, well, there'll be some kind of indication that you have gone beyond the limit. So there's one way of performing some validation. Fairly rudimentary validation. It's got to be there or not there. Another way, and this will allow us to perform more sophisticated validation, would be to make use of a method in the managed bean whose job is to validate that value. You can see from the example here that we're using an attribute called Validator, and we're using an expression language expression to highlight the bean and the method that will perform the validation. So that we will expect to find in that class called user a method called validateName, and it will have a certain interface and it will do the validation, and this is what the managed bean will contain. A method called validateName with these three parameters. It's important that those parameters are there because that's the interface that's required for this validation. The thing that we're particularly interested in for this is the object called value. That is the value that we're about to validate. This method is called validateName. We're the authors of that. We're also the authors of the facelet. We know that facelet is bound to a property called name. That property is of type string. Therefore, we know that this object called value should be of type string. So we can do a type conversion. We don't need to test to see if this is of the correct type or not, because we can see here that before validation is done, conversion is done. So we're guaranteed that by the time we come to do the validation, all the values are of the correct type. So we can simply take the value and convert it to the correct type. It might be an integer, it might be a double, it might be a customer. Whatever it is, that can be converted using the typecasting and stored. And then we can check, do our validations. Now in this particular example, we've got the rather spurious case that your name cannot be Jimmy. We're checking. If it's equal to Jimmy, we've got a problem, and so we've got to report it. The way we're reporting it is to set the component not valid, and then to add a message to the context. So let's take a look at this in a bit more detail. The component that arrives as a parameter is the UI component in the facelet. It will have an ID. That ID attribute, or the value of that ID attribute, will come in as part of this object here. We can then convert that and call setValid, passing in false as the value. So that means that the lifecycle will then examine all of these components, checking to make sure they're still all valid. And if there's any one of them that is not valid, such as here, it's been set to false, that will cause the lifecycle to abort. The control servlet will then redisplay the original view along with a message. And so the message we want to display is being set up here. We're going to add the message to the context. Well, the context is this context here. And the component is this thing here. We're going to call getClientID. That's the ID attribute value that is set in the facelet. So you might have a UI component, input text, ID equals username. Well, that's the value that will be used as the ID here. That error message, whatever we set up here, that error message will then be associated with that ID. Now that can be useful because in the facelet, there are ways of displaying the message right next door to the component to which that message relates. Instead of having them all listed at the bottom or all at the top, we can have them listed right next to the components that they belong to. And that's what the ID is used for associating that message with that particular component. An alternative is to use a validator object. So the validator method we looked at just now, that sits in the managed bean. A validator object is a completely different class, and its sole purpose is to validate whatever is passed to it. I'll show you an example in a minute that will clearly make this distinction and the consequences of it. You can see if we're going to use a validator object, we don't use the validator attribute. What we do instead is nest a validator element using a validator ID, and we'll see how that's done right now. That validator ID is this value here that is put onto that annotation. The @FacesValidator annotation declares this particular class to be an official validator within JSF, and therefore it will be managed by the control servlet. And when that validator is required, the control servlet will create an instance and then call this one method. We know there's only one method because the faces validator must implement the validator interface. And that interface defines just this one method. You can see that the parameter list is exactly the same here as it was in the previous example. Faces context, UI component, object. Faces context, UI component, and object. The other thing that this one can do is to throw a validator exception. So we can put in our code to do the validation. Now when we're using a validator method buried inside a bean somewhere, that method is associated with one property, and therefore we know exactly which component we're validating. And if we've got 3 components to validate, we could use 3 separate methods in that managed bean, one for each of those properties to do the validation. However, when we're using a validator object, that one validator object might be used for multiple components. The first thing to do within here is to work out exactly which component we're dealing with. So if the component getID equals, and then whatever value we've put into the facelet code, then if that's true, we know what we're validating and we can perform the check. Same as it was before. Convert that to a string, because we know it should be a string, and check to see if it is Jimmy or not. If it's Jimmy, well, instead of setting valid to be false, as we did in the method, what we're doing instead here is throwing an exception, a validator exception. We're using the same message, but we're throwing an exception instead. And again, that will cause the control servlet to abort the lifecycle, redisplay the original view with that error message. In the 2 projects that are available for download with this learning block, you've got an example of the validator method and the validator object. Let's take a look at the validator method to begin with. In index.xhtml, you can see that we're using a template. So if we take a look in the projects panel, there's a template file. That template file lays out the look and feel for the web application. And we're using that template file here and defining the code for the placeholder called content. It's got a form, header, paragraph with an input text, and we can see that this one is required, maximum length 25, with a validator attribute that identifies a particular method within the user bean. And then a little bit lower down in the next input text, we've got another validator, this time a different method within the same bean. So if we take a quick look at those, we can see we've got a method here called validate name and one here called validate age. They've got exactly the same interface. With validate age, we just cast value to an integer. We're safe to do that. Let me emphasize that again. We are safe to do that because the conversion takes place before the validation. And if the value that was provided would not convert to an integer, the conversion would fail and we'd never get as far as validation. So if we're in the validation stage, we know that this represents an integer, so we can convert it. And then having converted it, we can perform our checks, sending back messages should we need to. In the other project, we do exactly the same thing, except this time we're using a validator object. There's the annotation that says that this is a faces validator. And now we've got just one method called validate, which is going to validate both the name, the last name, and indeed something else. I mean, if we wanted to do the age here, we could do. And it just means that we've got this rather big if-else if construct that would run all the way through that method. If we're validating 40 different components in that one method, then we're going to have an if-else if with 40 options. Now you might or might not like that concept, but it gives you the option. You can use a separate validator object, or you can write, if you had 40 of them, you could write in your managed bean 40 different methods, one for each of the properties that you want to validate. It's preferences really, swings and roundabouts. That's up to you. And that's as much as we're going to introduce in this learning block. So by the time you've completed all those tasks on the tutorial worksheet, you should be able to identify and describe the different scopes, associate a managed bean with a scope using an annotation, use set, get and remove scope attributes, make an input field required, and then use 2 different ways for performing validation.